Hey everyone, today in this video we'll be talking about integration by trigonometric substitution. There are three main formulas in order to note how to integrate in of the form when we have an integral and it is either a squared minus x squared. We use the form x equals a sine theta, and then when it's a squared plus x squared under the integral, we use x equals a tangent theta. And finally, when it's x squared minus a squared under the integral, we use x equals a secant theta. So just remember those three formulas. Maybe write them down somewhere. Okay, so this is the first example. This is a basic trigonometric problem. So now, as I said earlier, we have to see which one of these three formulas does it correspond with. And we see that 4 minus x squared really corresponds with the first formula, which is x equals a sine theta. So we're going to use that one, the first one. So instead of u, for trig substitutions, we're going to use x, variable x. So sine theta. And then we're going to find the derivative. So the derivative of 2 sine theta is 2 cosine theta d theta. Okay, now what we could do, we could substitute in that x in the under the integrand. So 4 minus x squared, or 2 sine theta squared, and then 2 cosine theta d theta. We just simplify. 4 minus 4 sine squared theta. Okay, just leave out that dx at the outside. Okay, so now we could factor out a 4 in the integral, in the integrand, sorry. Okay, so now we could actually just factor out that 2, and the square root of 4 is just 2, so factor out a 4 outside. And we're left with 1 minus sine squared theta times cosine theta, since we factored out that 2, and that 4 that was inside the integrand. So now, in order to solve for the next step, we notice that 1 minus sine squared theta is a trig identity. If you remember your trig identities, 1 minus sine squared theta equals cosine squared theta. Okay, and the square root of cosine squared theta is just cosine. Cosine times a cosine is just cosine squared theta d theta. Now we could use a half angle identity. So we it's going to be 1/2 1 plus cosine 2 theta d theta. We're running out of room here, so let's move on over here. So 2 integral of 1 plus cosine 2 theta d theta. Okay, so now we could integrate. Let's move it over here now, back over here. So we have 2 theta. The integral of cosine 2 theta is 1/2 sine 2 theta. Okay. Okay, so I had to erase some of my previous work to make some extra space. And I also forgot to write the plus c, since this is an indefinite integral. And this is not the final answer. In order to find the final answer, we have to use a triangle and use the x equals 2 sine theta to solve. So if you remember your SOHCAHTOA, for sine is opposite over hypotenuse. And then since we have a theta, we need to solve for theta. So theta is just the inverse of this, x over 2. Okay, so now we could finish our problem. So 2 inverse x over 2. Okay, so now we have plus 1/2 sine 2 theta, but we could also just reduce this to 2 sine theta, cosine theta, and the 2's will cancel out. So all we're left with is sine times cosine. So now we solve for sine, which is x over 2 using the triangle, times cosine, which is adjacent over hypotenuse. So 4 minus x squared over 2 plus c. And then our final answer would be 2 sine inverse of x plus 2 plus x times 4 minus 2x, and then times 2, since one of the 2's cancel out, then plus c. And this is the final answer. Okay, now for this problem, it's just similar to the one we just did, but now the difference is that this one is this was a definite integral. The previous one was an indefinite integral. Now the difference between indefinite and definite for trigonometric substitutions is that with the indefinite integrals, we have to use a triangle in order to switch back theta in terms of x. But for this one here, the definite integral, we could just work it out directly. So now all we have to do here is just change the bounds of integration. So the lower bound 0, 2 theta, and theta will give us just 0. That's our new lower bound of integration. And our upper bound of integration is 1. So 1 equals 2 sine theta Okay, so 1 equals sine theta, so theta will give us pi over 6. So our new bounds of integration is 0 to pi over 6. Okay. Okay, since we just worked this out previously in the previous problem, I'm just going to skip through these steps. So we know that this will just give us 4 cosine squared theta, d theta. We're going to use the half angle identity once again. Same thing. So just pull out that 1/2. Give us 2, 0 pi over 6, 1 plus cosine 2 theta, and then d theta. Now we can integrate theta plus 1/2 sine 2 theta, and we're gonna integrate from 0 to pi over 6. Now this one is just 0, this whole side, because 0 plus 1/2 sine 0 is just 0. Okay, so now we just distribute that 2. So we distribute the 2 to pi over 6, we'll get pi over 3. distribute the 2 to 1/2, which just gives us sine 2 pi over 6, which is sine pi over 3, which is radical 3 over 2. And this is our final answer.